Graphs can be traversed in two ways. The first one is the breadth first traversal, that is the BFS, and the second one is depth first traversal, that is the DFS. Over here, we will be discussing about DFS. The strategy that is followed under DFS is to search deeper in the graph. It traverses a single path of the graph as far as it can go, that is, until it reaches a node all of whose successors have been visited, and then comes back to the source parent of that particular node. A stack can be used to eliminate the recursions in DFS. Now coming to the topic, algorithm involved in DFS is to create a recursive function that takes the index of the node and a visited array. The unvisited nodes will be marked as 0, which are untouched. The queued nodes will be marked as 1, which are in the process. Third, visited nodes will be marked as 2, which have been visited. Mark the current node as visited and print the node. Traverse all the adjacent and unmarked nodes and call the recursive function with the index of the adjacent node.
Since we know that the DFS algorithm uses a stack to remember to get the next vertex to start a search when a dead end occurs in any iteration. So as you can see, there's a graph at the top left corner of the screen. We will be traversing this graph using a stack and using a DFS algorithm. So the first column, which is a stack, it shows the element that we are pushing in or popping out of the stack. The second column shows the current status of the elements that are being popped out or pushed in. The third column states or it makes a note of operations that we have made. So starting with the S node, we have chosen the start vertex to be S. So after S, since we are traversing in an alphabetical order, the adjacent to S are A and C. But since we are traversing in an alphabetical order, we'll choose A, and initially since the stack was empty, it's empty over here. And then we'll push S into the stack and we'll mark S as visited node. And then we'll push A into the stack and we'll again mark it as the visited node. And the status of it will be 2. Then coming to the node A, we can see it has 2 adjacent nodes, S and D respectively. But since we have already traversed through S and then visited it and the status of it is 2, we will shift our target to D and hence we'll push D into the stack. Now, since as you can see here, the adjacent to D is A, B and C, and we have traversed through A and it's visited and the status of A is 2, we will shift our target to B and C. Now comparing amongst B and C, we'll choose B since it's traversing in an alphabetical order. So we will push B into the stack. Okay, we'll push B into the stack. Now, as you can see, there is no adjacent node to B which hasn't been visited yet. S is also visited initially, D is also visited. So what we'll do is make a backtrap and we'll come back to D. And since we know that there's an adjacent node to D which isn't visited yet, which hasn't been visited yet, which is C, and the status of C is 0, so we will pop B out of the stack, we'll come back to D, and we'll push C into the stack. So now C is visited and its status becomes 2. As C does not have any unvisited adjacent node, so we keep popping the stack until we find a node that has an unvisited adjacent node. In this case, there's none and we keep popping until the stack is empty. So this is the final status after we are done with traversing using DFS algorithm. Here I'll be showing how DFS works for an undirected graph, a small graph, and it will be a logical representation. Start vertex is the vertex from where we will start our traversal. Supposingly, if I choose 1 to be a start vertex, it will start traversing from 1 to the adjacent node of 1, which is unvisited. And also it will traverse in an ascending order. That means although one has adjacent nodes as 3 and 2, but it will traverse 2, 2 and not 3 because 2 comes before 3. So as you can see, there's a parent column and a visited column. Here, parent column is the column which states, supposingly, if we see that against 2, 1 is written, which means that 1 is the parent of 2, since we are traversing from 1 towards 2. So here 1 becomes the parent of 2. In front of 0, it's written 2, which means that 2 is the parent of 0, since we are traversing from 2 to 0, and so on. At last, you will find that there is no parent for 1. Why? Because we have started a traversal from 1. And since we are starting our traversal from 1, there will be no parent for 1. It itself is the parent for its adjacent nodes. So there will be blank in front of 1. Now talking about visited column, you can see that initially it was F for all the nodes, which means the status of each and every node initially was false. That means every node was unvisited. And as we started our traversal, it changed from F to T, which is the true, which means that the nodes are being visited as we are traversing ahead. Now, since we are completed with the traversal, you can see all the nodes are turned to T, which means that all the nodes have been traversed and we're done with it. And here you can see it's a stack, it's a depth. You can see from 1 we're traversing to 2 and then to 0. It's a hierarchy. And then you can see there's a change in the hierarchy over here, because after 0, since there's no node adjacent to 0, we'll backtrack to 2 and then to 1 and then come back to 3, which is the unvisited adjacent node to 1, and also the least in number. So we'll backtrack from 0 to 3 and then from 3 to 7 and so on. This is how it works.